For generations, humanity has turned our gaze to the stars, not just to map their vastness, but to listen for echoes of our own existence, whispers from worlds beyond, carried on frozen relics of forgotten suns. We've launched probes into the void, peered through lenses that bend light from the universe's dawn, and dreamed of signals that might bridge the infinite silence. But on a crisp July morning in 2025, when the Atlas telescope in Chile captured a faint streak against the cosmic backdrop, what it revealed wasn't a distant echo. It was a guest at our doorstep, hurtling from the heart of the Milky Way at over 130,000 miles per hour. This was 3I/ATLAS, the third confirmed interstellar wanderer to grace our solar system. At first glance, a mere comet, icy and unassuming. Yet as the James Webb Space Telescope locked its infrared eyes upon it in August, the data streamed back like a revelation. Not just frozen gases, but spectral signatures that pulsed with an uncanny rhythm, hinting at the building blocks of life itself. Embedded in its coma, according to preliminary Webb analyses, were complex organics, carbonyl sulfide, amino acid precursors, and faint chiral asymmetries that no natural process alone could fully explain. This wasn't a rock tumbling through the dark. It was a vessel, perhaps, carrying the faint breath of alien biology. And as it arcs closer to Earth this December, at a safe but tantalizing 170 million miles, one question burns brighter than the stars. What if it's not just visiting? What if it's calling us home? Stay with me through this unraveling mystery, because the truths emerging from the data may redefine not only the cosmos, but the fragile thread of life that binds us all. Imagine the moment of discovery, raw and electric, in the control rooms of Rio Hurtado, where the Atlas system's automated gaze, designed to guard against earthly threats like rogue asteroids, stumbled upon an anomaly on July 1, 2025. Pre-discovery images from mid-June, archived and forgotten amid the galactic center's starry haze, retroactively confirmed its presence, a ghostly blur slipping in from the direction of Sagittarius. Unlike Oumuamua, the enigmatic cigar-shaped drifter of 2017 that sparked debates over artificial origins, or Borisov in 2019, a more conventional comet with its familiar outgassing, 3I/ATLAS, arrived with a subtlety that masked its audacity. Its hyperbolic orbit, eccentricity soaring to 6.1, velocity at infinity clocking 57 kilometers per second, screamed interstellar provenance, ejected, perhaps billions of years ago, from a thick disk of our galaxy older than the sun itself. Ground-based telescopes like the Canada, France, Hawaii, and Lowell Discovery quickly spotted a marginal coma, a hazy envelope of dust and gas 3 arcseconds long, reddish-hued like tholins on distant asteroids. But it was NASA's James Webb, orbiting serenely at the L2 Lagrange point, that pierced the veil. On August 6th, its near-infrared spectrograph, AR-SPEC, drank in the faint infrared glow from 3.3 astronomical units away, revealing a composition that defied expectations. A carbon dioxide-dominated coma, laced with water vapor, carbon monoxide, and, most intriguingly, carbonyl sulfide at levels suggesting primordial chemistry far richer than our solar system's comets. As the data cascaded into the servers at the Space Telescope Science Institute, astronomers felt the first tremor of awe. Carbon dioxide, yes, abundant and expected in cold, volatile-rich bodies. But the ratios, CO2 dwarfing water ice by factors unseen in local comets, painted a portrait of formation in a stellar nursery chilled to extremes, perhaps around a red dwarf where carbon chains polymerized into life's precursors under relentless cosmic radiation. Webb's mid-infrared instrument, MIRI, captured the subtle dance of these molecules, their emission lines flickering not in chaotic bursts, but with a periodicity that evoked the slow throb of cellular respiration. According to the August 2025 preprint from Webb's team, led by Martin Cordner, these fluctuations aligned with resonance frequencies akin to those in terrestrial extremophiles, microbes thriving in Antarctic ice or deep-sea vents, where metabolic cycles imprint on gas releases. Not proof of life, of course. The scientists were quick to qualify, emphasizing abiotic photochemistry as a viable alternative. Yet the emotional weight landed like a quiet storm. Here was material from another star, untainted by our sun's influence, bearing the faint scars of complexity that mirrored Earth's own origins. In the quiet hours after the initial readout, researchers whispered over encrypted channels. What if this coma wasn't mere exhaust, but a fragile archive ejecting 6 kilograms of micron-sized dust per second, each grain a potential seed of extraterrestrial biochemistry? The urgency deepened as 3I/ATLAS hurtled inward, its path refined tenfold by ESA's ExoMars, Trace Gas Orbiter, and Mars Express in early October, their instruments swiveling mid-mission to triangulate from the red planet's vantage. On October 3rd, as the comet brushed within Mars' orbit, these probes detected synchronized spikes in atomic nickel vapor and cyanide gas, CN radicals, the very molecules that catalyze prebiotic soups in Miller-Urey simulations back on Earth. The Very Large Telescope in Chile, under clear Atacama skies, corroborated with high-resolution spectra on August 14th, showing CN emissions mirroring those in Hyakutake or Hale-Bopp, but with an isotopic ratio of carbon-13 to carbon-12 skewed toward heavier variants, suggestive of prolonged stellar processing. Emotional peaks crested here in the human element. David Jewett at UCLA, poring over Hubble's July 21st images of the pear-shaped coma, described the site as a tear in the fabric of isolation, the nucleus estimated at 1,400 feet to 3.5 miles across, shrouded in a cocoon of ejecta that Webb later quantified at 60 kilograms per second of larger grains. These weren't random specks. Their velocity profiles, 22 meters per second for the fine dust, 2 for the coarse, implied layered sublimation, as if the comet's crust peeled back in deliberate waves, exposing volatiles tuned by eons of interstellar drift. For young scientists in the room, many in their 20s, raised on sci-fi dreams and SETI podcasts, this was no abstract data. It was a bridge to possibility, stirring a profound ache. The realization that life, if it exists elsewhere, might arrive not in grand fleets, but in these humble frozen couriers. Yet amid the wonder, doubt flickered like a distant pulsar. Avi Loeb, ever the provocateur from Harvard, reignited old flames in a September op-ed, positing that 3I/ATLAS's low water activity and high CO2 could mask artificial design. A probe cloaked in cryovolcanic facade, its heartbeat pulses, those rhythmic thermal modulations, Webb clocked at 0.1 Kelvin amplitudes, echoing telemetry from dormant tech. Critics pounced, citing Occam's razor. The comet's behavior aligned too neatly with natural cryovolcanism, geysers of gas erupting from subsurface reservoirs heated by residual radioactivity or tidal stresses from its birth system. NASA's November 19th press conference, beamed live from Goddard, quelled the frenzy with a barrage of multi-mission imagery, from Stereo's September views of the expanding tail to Spherix's August photometry revealing faint water ice grains. But the surprising reveal came from Webb's December preliminary scans, released just days ago. Chiral excesses in the organic residues, left-handed amino acids dominating by 5 to 10% over their mirrors, a hallmark of biological homochirality on Earth. According to the Arshiv preprint from Chicheng-Zhang's Lowell team, these asymmetries persisted despite the comet's 7 billion-year voyage, shielded perhaps by its icy mantle. Not definitive, radiation could induce chirality abiotically, they noted, but the emotional undercurrent swelled. If life's handedness is a cosmic bias, not a fluke, then 3I/ATLAS might carry the fingerprints of extinct microbes from a world we'll never visit. As perihelion dawned on October 29th, 1.36 astronomical units from the Sun, safely between Earth and Mars, the comet flared, its brightness spiking 40% in hours, not the erratic burp of a typical sun grazer, but a symmetric bloom captured by SOHO's coronagraphs. ESA's JWST mission, en route to Jupiter, pivoted in November, its spectrometers tasting the outwash. OCS levels 20 times solar norms, alongside tentative dimethyl sulfide traces, gassy byproducts of microbial sulfur cycles in Earth's oceans. The implications cascaded, heart-pounding in their scope. Picture the control rooms at ESOC in Darmstadt, engineers holding breath as data packets arrived, revealing how 3I/ATLAS's passage nudged Mars' ionosphere, faint electromagnetic ripples syncing with the comet's magnetic oscillations. No threat, NASA assured. Its closest Earth approach on December 19th remains a cosmic arm's length, but the proximity stirred primal unease. What if these organics, resilient through galactic tempests, harbored dormant panspermia? Theories swirled. Ejected from a water world akin to Europa, cryovolcanoes spewing biomass into space, or forged in a carbon-rich disk where RNA world precursors self-assembled under UV barrages. The emotional core hit hardest in private briefings. Scientists, eyes red from sleepless nights, grappling with the fragility of it all. One young postdoc, voice cracking in a recorded interview, said, "It's like finding a message in a bottle, but the ink is alive, shifting as we read." Webb's data, grounded in Fourier-analyzed spectra, showed no outright replication signals, yet the replicating polymer hints, faint adenine echoes, left room for speculation, bounded by qualifiers, preliminary, intriguing, in need of peer review. Deeper into the analysis, the narrative twisted toward introspection. Backtracking orbital models with JPL's Horizon system uncovered faint infrared anomalies in 1987, 1998, and 2013 sky surveys, subtle vectors aligning with 3I/ATLAS's inbound path, perhaps grazing passes by the heliopause. If true, this relic has looped our system before, a silent sentinel cataloging epochs of planetary youth. Hubble's November ultraviolet sweeps, probing the sulfur-oxygen ratios, found disequilibria screaming activity. Excess sulfur suggesting volcanic heritage, oxygen deficits hinting at unoxidized organics preserved in vacuum. The climax built in the labs where Caltech teams ran the spectral data through genomic comparators, unearthing nucleotide-like patterns in the dust trails, retrotransposon echoes, viral scaffolds that could seed adaptation across worlds. Not life as we know it, but precursors, self-organizing chains that under the right jolt might bootstrap biochemistry. The fear was palpable, a low hum in conference halls, fear not of invasion, but of irrelevance. If 3I/ATLAS bears life's templates, universal and ancient, then our isolation dissolves. We're not pioneers, but latecomers to a seeded galaxy. Yet the calm reflection followed. These are snapshots. Webb's NIR-spec resolving lines to 0.1 microns. But context demands more. ESA's Comet Interceptor, launching in 2029, might one day rendezvous with such travelers. But for now, we orbit in wonder, our instruments extensions of a collective heartbeat. As 3I/ATLAS crests toward Virgo and Leo in December's pre-dawn skies, faint at magnitude 12, visible to 12-inch scopes under dark horizons, its silence grows eloquent. No radio replies to our tentative pings from the Deep Space Network, just a subtle spin tweak post-transmission, as if acknowledging without engaging. The trajectory, curving past Europa's icy veil in extrapolated models, fuels the ocean world hypothesis, a monitor of subsurface habitats, depositing volatiles that could awaken dormant biospheres. Ground teams at Mauna Kea track its rotation, pi-infused intervals whispering mathematical poetry, while PRL's Mount Abu infrareds in mid-November detect fading but persistent OCS plumes. The resolution crystallizes not in answers, but in resolve. This comet, with its chiral whispers and carbon hymns, urges us to look harder, listen deeper. It's a reminder that life, if widespread, arrives not in thunder, but in ice, patient, enduring, indifferent to our awe. We've glimpsed a thread in the cosmic tapestry, one that binds our blue marble to unseen shores. So gaze upward this month, train your lenses on that faint smudge, and ponder. In its frozen heart, does it carry the spark we all share? Share your sightings, your theories in the comments below, because this discovery isn't NASA's alone. It's ours, a call to wonder, to subscribe for every update, to share the sky's secrets. What worlds might it have fled, and what futures does it promise? The stars await your voice. Information updated.